Hi, my name is NURUL. My metric number is 304473. I will explain how to answer question 1A, which involve partial differentiation and interpreting economic relationship from a given market model. Okay, let's start with question 1 Roman. Partially differentiate Q star with respect to P sub S. So we are given this equation for quantity Q. Q star equal to E plus F times A plus E plus C P sub S minus D P sub C plus T P sub I close bracket over F plus B minus T P sub I. So our task is to partially differentiate Q star with respect to P sub S, which is the price of substitute. Since all the other variables are constant with respect to P sub S, we focus only on the term that include P sub S, which is F times open bracket A plus E plus C sub CP sub S minus D P sub C plus G P sub I over F plus P. So our answer for this question is the partial Q star with respect P sub S equal to FC minus F plus P. Now let's move to the next question, second Roman. Referring your finding in 1 Roman, state the direction of relationship between Q star and PS. We look at the sign of the derivative we just found. Since F greater than 0, C is greater than 0 and B also greater than 0, we know that FC over F plus B is greater than 0. This means there is a positive relationship between quantity demanded Q star and price of substitute PS. Next question 3 Roman. Briefly explain the effect of change in PS on Q star. When the price of substitute good increases, consumers are more likely to switch to original product, which becomes relatively cheaper. As a result, demand for original product increases, so the quantity Q star increases. That's why a rise in PS leads to a rise in Q star.
Hello, here we are given the demand equation, which is Q star equal to dP star Y, with dd over dP star less than 0 and dd over dy more than 0. And for the supply equation, we have Q star equal to SP star R, with ds over dP star more than 0 and ds over dr more than 0. So to verify that the condition of the implicit function theorem are met or not, we have to write the equilibrium as an equation. So we have two implicit functions here, which is the first one is F1 Q star P star Y R equal to Q star minus D P star Y equal to 0. And the second one is F2 Q star P star Y R equal to Q star minus SP star R equal to 0. So for the second step is we have to find the total differential. So the first total differential equal to dQ minus dP star minus dy equal to 0. And the second total differential is dQ minus SP star dP star minus SR dr equal to 0. And then we have to rearrange endogenous equal to exogenous. So dQ minus dP star equal to 0. And the answer, the second one is dQ minus SP star dP star equal to SR dr. So for the next step, we have to convert to Jacobian metric, which is Jx equal to B. And the last step, we have to find the value of J. So to find the value of J, here we have is J equal to 1 times negative SP minus 1 times negative dP equal to negative SP minus negative dP equal to minus plus minus and equal to minus plus minus, and we got the answer is negative. So it is unequal to 0. So for the conclusion, we can conclude that condition of the implicit function theorem are satisfied. So we can locally solve for P star equal to P star Y R.
Question 2 Roman 2. Analyze the effect of an increase in the income Y on the equilibrium quantity and price of the good in the market. First step, we make R equals to 0 as we are using income to determine our equilibrium quantity and price effect. Second step, we use Cramer's rule to get the positive and negative relationship where dQ over dy equals to J1 over J. Now we have to get the value for J1 first, and the value for J1 is dy SP dy. Then we take the equation to find dQ over dy and we will get a positive value which is more than 0. Therefore, an increase in income leads to an increase in the equilibrium quantity as we get positive relationship between income and equilibrium quantity. Next, now we have to find equilibrium price. First step, same as the previous one, we make R equals to 0. Second step, we use Cramer's rule to get the positive and negative relationship dp over dy equal to j2 over j1. Now we have to get the value for j2 first, which is negative dy. Then we take the equation to find dp over dy, and we will get a positive value which is more than 0. Therefore, an increase in income leads to an increase in the equilibrium price, as we get positive relationship between income and equilibrium price.
MPC, marginal product of capital, means how much extra output we get if we increase capital by 1 unit, holding labor constant. Step 1. Differentiate Q with respect to K. This means if we increase capital by 1 unit, keeping labor constant, the output Q will increase by an amount equal to 0.4 times K to the minus 0.6 times L to the 0.6. So, the marginal product of capital depends on both capital and labor. If capital increase, this value may decrease due to diminished rate. We move to question B, marginal product of labor. Now we find the marginal product of labor, that is how much extra output we get from increasing labor by 1 unit. Step 1. Differentiate Q with respect to L. The marginal product of labor equals 0.6 times capital raised to the 0.4 multiplied by labor raised to the power of negative 0.4. Again, this depends on both inputs. If labor increase, the marginal product of labor usually decreases too, due to diminishing marginal return.
C. The average product of capital is defined as the total output Q divided by the amount of capital K. The formula is FPK equals to Q divided by K, and we will get our answer is K power of negative 0.6, L power of 0.6. B. The average product of labor is defined as the total output Q divided by the amount of labor L. The formula is APL equals to Q divided by L, and our answer we will get K power of 0.4, L power of negative 0.4.
Now let's move on to part E, where we need to interpret the numbers 0.4 and 0.6 in the Cobb-Douglas reproduction function. Q equals K to the power of 0.4 times L to the power of 0.6. These two numbers are called output elasticity. What does that mean? 0.4 is elasticity of capital K, 0.6 is elasticity of labor L. These elasticities tell us how responsive output Q is to changes in input. 0.4 means if we increase capital K by 1%, output Q will increase by 0.4%, holding labor constant. 0.6 means if we increase labor L by 1%, output will increase by 0.6%, holding capital constant. So, the numbers 0.4 and 0.6 represent how sensitive output is to each input, and together they tell us the type of return to scale the firm has.